I hope this topic will be interesting to you. I want to talk about how to optimize CRDTs, what I did in the past, where we were, and where we will get probably with YJS. Just a little bit about YJS. YJS started like 10 years ago as my bachelor thesis, and I've been working on it ever since. I thought I would be done at some point. I never was. And I've been optimizing YJS ever since. And you have to think back like 10 years ago. What was that? 2014. God, am I old. YJS was always really fast because I'm like a performance nerd. I like to optimize stuff. That's what I get a kick out of. And back in 2018, there was actually a paper that was called Real Differences Between OT and CRDT for Co-Editors, which was often used as an argument against CRDTs for using that in collaborative text editing applications. And every time there was a Hacker News post about CRDTs or YJS or anything, there was this one person who posted exactly this paper that badmouthed YJS. Of course they did. And yeah, CRDTs are a bit more memory hungry and blah, blah, but they're really cool and also really useful and easy to use and easy to sync. And like today, CRDTs is the most used approach to build any kind of collaborative editing framework application. Like seriously, like YJS is being downloaded 740,000 times a week. The next best thing in OT land, which is what the author of the Real Differences paper uses, is being downloaded 7,000 times. So. Thank you. Yeah, I'm super happy about that. But I still like ShareDB, honestly. It's really cool. It is revolutionary because it existed also 10 years ago. And back then, it was better than YJS, honestly. YJS now has a lot of integrations. I heard a lot of talks today mentioning YJS as well and YJS integrations. I'm still thinking about CRDT optimizations. This is CRDT benchmarks in 2020. YJS was far ahead above anything else. It was sometimes like even like 10,000 times faster than the next best thing. And if you look at some of the things that I mentioned in my CRDT benchmarks repository, just look for it. Yeah, these are all test cases that are reproducible. So here, for example, the time it takes to apply this real-world editing data trace in YJS was like 5 seconds, really cool. In AutoMerge, it was 560 seconds, which was insane, like took forever. And I had these really large benchmarks, and there was no CRDT anywhere that couldn't even run it because it used too much memory. But today they caught up. So YJS is still really fast, and I still believe YJS is the best trade-off anywhere, but the other CRDTs really caught up in what they did, and they used some of my approaches, they invented some new approaches, and I also copied from them, and it's been a really fun time, honestly. You could look at each of these things here separately, and some of these benchmarks, YJS still wins. In others, it's like comparatively, I think it's always a trade-off, but I want to say like most CRDTs that you can find today are usable for any kind of text editing application. So co-editors, right? So we have a lot more CRDTs being used for co-editors. That is a really good thing. Generally, it's just a trade-off now. Maybe get a bit more performance if you use this other CRDT for a certain use case, but you have worse behavior in the other case. You might use more memory, blah, blah. It's a trade-off. Everything is a trade-off. And I want to mention this this blog post by Seth Gentle, CRDTs go brr. A lot of people read it. I guess everyone here knows it. It's a really good blog article. And I love that it generated a lot of excitement for CRDTs. And mentioning YJS also and how fast these CRDTs are now. And he implemented this awesome CRDT that is 5,000 times faster than anything else. So we get these exponential improvements now. But he only measures this one thing, like insertion time. How fast is it to insert a character? And in YJS, if you measure this down, like you'd use something like a microsecond to insert a single character, probably even faster than that. In Seth Gentle's CRDT, you would use less than a nanosecond to insert a character. But I'm thinking about this, like how fast do I need to type so this becomes relevant? Okay, but it's still a really cool thing. Also, it's a trade-off, right? Because now this Seth Gentle's implementation uses skip lists, which uses more memory in exchange for faster insertion time. And yeah, I could talk for hours about trade-offs. And CRDT implementations are just trade-offs, basically. And choosing the right trade-offs is, in my opinion, what should be my job as an author of a CRDT. All of these other frameworks, basically, any other popular framework is now built on Rust, basically. There is Bartosz, who implemented YRS, the Rust implementation of YJS, and there's a port of it that is called Wasm, and that is what I'm listing here in the second category. We have Laurel written in Rust. We have AutoMerge now completely written in Rust. There's no JavaScript implementation anymore. There are many other CRDTs as well, all written in Rust, and then being ported to Wasm, where Wasm is this new language that is supported. It's not really a language, it's an assembly language that is now supported by all the web browsers, Node.js, Bun, and wherever. It's like the new assembly language for the web. It's really cool, check it out. So the pro is, if you use assembly language or any kind of native language, you have much more control over how you can manage your data. I'm so envious as a JavaScript developer managing my own data, like being able to manually garbage collect objects or decide not to do so. That is such a cool feature. I needed so much time to optimize that in YJS. And now they all get that for free. But there's also some cons, in my opinion. If you like, I'm kind of hesitant to implement it in Rust or like recommend everyone to switch to Wasm, because Wasm is just less inspectable. You get really bad error messages if something goes wrong, and the tooling is, I don't like it. It's really bad tooling. And the Wasm binary, want to go back to the benchmarks here, the Wasm binary is actually really huge. Look at Wasm, which has, from the Rust implementations, the best binary size. It's 200 kilobytes. YJS is 20 kilobytes. I know, you probably don't care, but to me it's a lot. Yeah, and it's getting even worse. So Wasm currently, if you want to ship that to a browser, like to web applications, you need to base64 encode it. I hate base64 encoding. Basically, you take a beautiful binary string of data that you thought about a lot, and then you add a 33% overhead, and also add the fact that base64 encoded messages are really bad as compression targets. Here I encoded these two integers as base64, and bam, we have double the message. So 2 characters are 4 characters as a string. This is so bad. And also, in the browser, it's really slow to decode. There's no fast base64 decoder in the browser. I hate that. So why do we need to bundle Wasm to the browser and then include it in our JavaScript file as a huge string, basically breaking any kind of editors? Try opening it in Vim or in VS Code, or I'm not sure what your favorite editor is, but the clear winner is Vim, obviously. But it's getting really slow because it's a huge string and the parser needs a long time to read it. It's just really bad experience in my opinion. So I tried to implement my own base64 encoder, and I was like, well, how do I want to do this? I tried it in JavaScript. It's still really slow, so I used some WebAssembly, but I didn't use Rust. I used WAST, which is the WebAssembly text format. And it's been my favorite. It's such a fun experience to write assembly language myself. Seriously, I get so much power. I now control my own memory. How cool is that? And I can use some magical features like SIMD operating on 16 bytes at once, which is insane. I can make some things 16 times faster, but it's also really hard to develop Wasm. So I don't recommend it to everyone, but it's been a really fun project. You should try it out. If you go to this URL below, I published some of my findings there. Like I wrote some things in Wasm, and I feel I can do a lot of things really quickly if I write it in Wasm directly. Here an example, I wrote a base64 encoder. The browser implementation for encoding, it takes 4 milliseconds to encode a 52 kilobyte document. In my Wasm implementation, it only takes 42 microseconds. It's quite an improvement, but also who cares? It's only 100 times faster. It's microseconds versus milliseconds, who cares? I still think it's impressive from some perspective, but I don't know. But the impressive thing for me was that these Wasm modules are actually really small. Like writing the base64 encoder compressed in pure Wasm is only 400 bytes. Like think about it. Like what kind of program is only 400 bytes? That is really small. So maybe is the future of YJS maybe that I write everything in Wasm? Nah, it's not. I don't think so. But there are some features that I really like to use. So WebAssembly now supports garbage collectible objects. So WebAssembly actually is not just binary and working with binary objects. Now we can actually work with garbage collectible objects now. And currently only array and structs are supported, which is super limited, but also kind of cool, because we can also interact with JavaScript objects. So we can store JavaScript objects in Wasm objects just for reference, and then we could build some new data structures in Wasm that are really fast, maybe. That's my thinking. We have a really small binary size, and we have manual memory management. We can add some really cool performance improvements, basically, and we can build data structures that we could never implement in JavaScript itself. So that's kind of where I want to go with performance optimizations in JavaScript. But there are still some disadvantages in using Wasm in production. Mainly, there are just very few people who can understand Wasm. The tooling is not complete. The bundler support, for example, is basically non-existent. So still, we have bad bundler support when we want to integrate Wasm into a JavaScript file. We still need to do base64 encoding. I don't want to do that for my users, never. So at some point, the browsers will ship base64 encoding, and that's the point where I'm going to implement Wasm optimizations in YJS. For now, I'm not going to do that. But this is where I want to go, and I really recommend you to maybe play around with Wasm. Maybe it's the future. It's definitely a really fun experience to work with it. Anyway, this is me. Sorry for the short talk. And find me there, and looking forward to Bartosz's talk. And thank you.